Hopefully that's working. Okay, so right, so let's get started with the actual modeling. So for Rhino interface, I was explaining that you have these tabs up here to help you for selections, but that it's primarily a command-based software. So as we type in commands, say if we type in line, you'll see that there's an option after your command. So for instance, here we have start of the line. Start of the line is going to be a point, right? Point to point that creates a line. So if you type in, say, 0, 0, 0, that will be the origin point of your line. Now notice that my line is moving orthogonally in space. That's because down here, if you see this little selection tab, I have it on ortho. If I unselect that, now I have a full range of motion from that origin point. Okay, and that is true in XY plan, like top view space, which is where we are right now, right? This is our X, this is our Y, but there's also a Z axis, right? So if I were to look at perspective view, I actually have a Z axis as well here. As I'm drawing in perspective view though, it will try to align to this C plane, which is the coordinate system that we are oriented in. So Rhino has, it's a 3D modeling space. So what it tries to do for you is it gives you the option of a orientation. And that's something to be noted for not just Rhino space, but then also Grasshopper space. You'll be wanting to control which plane you are modeling in. So if we go back to top view here, you can see that if I hold my shift key as well while I'm making this line, I can make it straight. Okay. So if I hold that down, I have created the end of line. I could also have typed in a coordinate. So line, we'll say 0, 0, 0 again. And if I hold my line over here, I can do 2, X, Y, Z. And now it will have gone 2 and 3 units over and up. If I look at my perspective view, it should not have gone into the Z-axis because my Z was 0. So if you did well in geometry, this is a really great, great space for you. You can use those skills to, figure out where you are in space and where you want things to be in space. Okay, so that's just a simple understanding of what we're looking at when we see this coordinate system in top view and in these other views. So right, if I go to the front view, if I turn off my surfaces and you were on the wrong layer. Should be in surfaces, there we go. I should see a single line because I did not work in the Z-axis at all. I go back to the top view, that's where I'll see my geometry. Another thing to note is that when you open Rhino and you start a new project, you will have an option for, let's see if we can do this quickly. My Rhino 6 has been kind of slow to start up lately. But when you're opening it, you should be able to choose what kind of units you want to work in. So for instance, this one, when I opened a new Rhino file, I opened it as a large feet units because I want to create a tessellated structure that I expect people to be underneath or within, or it's supposed to be a people-sized structure. If you want to work on smaller objects, you can select. Let's see, here we go. I could have also done new up here if I do this, but I'll just open it regularly so you can see. Oh, okay, it didn't do it. Never mind. Okay. Maybe it's because I already have it open. Well, the thing that you can see, so you can see that mine is in feet. I don't know why it didn't do that. So it must be because I have it open. All right, so you can go to here if you right click on your feet, and you can change your unit settings. So if you have already opened it and it asked you what, or you already chose what kind of what type of units to work in, and you say you're in inches and you don't want to be, you can go to here and you can change that from inches to feet. You can also work with your absolute tolerance. So this is the tolerance of your selection. So if you want to work very minutely, you probably don't need that for feet, but say maybe for inches you wanted to be super precise, you could add another 0 in here. I don't suggest it. Usually these defaults are fine, but at least you know you can control it there. Distance display. So if you are you're trying to measure something, right? You want to see how big whatever you're working on is. You can go to here and you can change it from decimal to fractional to feet and inches, which is typical for architectural drawings. So it's probably a good idea to have that on when you are, if you are trying to use this information as a export to your boards. However, sometimes you will place that information in yourself. For instance, in InDesign, I know I've measured in Rhino space, and then I input that information on my own with my own line work to make it pretty in InDesign after the fact. It's up to you. Typically, you have to do some adjusting to the dimensions in Rhino space to get them to the graphic level that you want. So it's just up to you and whatever your final outcome. I typically leave it on decimal. Sometimes I'll work feet and inches. It's just a matter of what you're doing. And then the other thing to note for us new to Rhino folks is the interface here with the grid. So this grid, you can see I have different units, and when I typed in 2 and 3, this went over 2 exact spaces and up 3. Your grid might be set up differently. For instance, I noticed my default over here was set up insanely small. And I don't know if I did that at some point. It shouldn't be that way because I do not want to work like that. I had to go in and change the grid so that it was to my benefit. And you can do that by typing in grid. So that's a command that you can use. And if you, which as I start to type in commands here, you should be following along, but then you might also want to have a notebook next to you and just write those down as I say them. You can type them in later and practice these things. But it'd be good to have a working list for your future self. Okay, so the grid is a nice tool for you because you can turn on grid snap if you want to use it as a guidelines to for your modeling. So this would mean that as I draw a line, it will snap to each one of these nodes. Okay. So up here is where you can create those nodes. So wherever those lines intersect. I have my minor line spacing set to 1, which in this world is feet, so that's 1 foot. So 1 foot in each direction, and then my major line interval is set to 5. Now say I wanted to change this to 10. So I can either click on this to change the option, or I can type in A, enter, and then I have the option to change this to say 10. Okay, so I clicked it, say 10, and now you can see that my major line grid spacing has gotten larger. Extents here, you can change those as well if you click on it. You can also type in the extents, so if you type X, you have the same option again. or no, sorry, E. And then you can change it back. Okay. This is also useful to know how you can turn off a grid. So if I say yes, I can to the show grid, it actually changes it to no. So all it is a Boolean command. So I click on that, yes, and it changes it to no. Click on no, changes it to yes. Same for the show grid axes. Okay, I can turn that off and on. And then show world axes, that is the this down here, this little icon. This kind of tells you where you are in your C-plane world. So this is X and this is Y. This is a good little guide for you, especially when you look in perspective view, right? It'll always help orient where you are in space. Okay, and that's also useful then when you're working in Grasshopper, because sometimes you have to remember where you are in X versus Y versus Z, and it can get tricky. So it's a good little tool. Okay, so I'm going to show my grid axes right now because I do want to see that. And then apply to active viewport is just, you can choose whether it's just this one or it's all viewports. So if I say all viewports, now my other views should be fixed. Yes, look at that, nice. Okay, so enter to close out of the command. And now we are in correct modeling space. I'm going to delete this, he's annoying. Okay. So I just right-clicked to control these viewports. You can right-click and you can delete, you can rename, you can hide them. I mean, the right-click is what you can use to for your options. For some reason, he's being annoying. Oh. Okay, I don't know what I did there. All right, so let's start with our first assignment, which is the folded plate structure. Okay, so to start, we're going to type in a new command, which will be rectangle. Okay, so you can just type in rectangle here. You can also select rectangle in this panel over to your left. Okay, both of them work the same way, where you have a first corner and with a certain point. Okay, this is where my grid selection is really nice. I can just click on 0, 0, and then click on the grid to wherever I want my next point. That's if I have a nice fixed distance. So say I want it, 3, 4 panels over, up. This is 10, right? Because I created my grid from each of these to be 1 foot, and then for each of my major grid lines to be 10. So for simple things like this, it's kind of useful to have your grid snap on. Okay, if I have my grid snap off and I try to create my rectangle, I will have to type in where I want my first corner. So if I do it that way, then I need to type in. I usually like to start with 0, 0, 0 because then I know exactly where it is in space. Especially if I have my perspective view open. Sometimes if you click randomly in space and you don't have your grid snap on, or even your O snap, and you don't snap to anything, your point can be a million miles away. I mean, not a million, but like very far off from where you thought you clicked. And so it's just a good idea to know where you are, where you're clicking in Rhino space. So you want to make sure when you do that you're looking in several views and not just the one view. Okay, so back to rectangle. Okay, so I'm going to do 0, 0, 0, and I'm going to turn my grid snap on. I will make it say 4 by 10. Okay, so that we have a nice little rectangle to start off with. Now, what I can do here is I can do two things. So if we look at what we want to make, okay, so I made two different things. The first one is a very simple folded plate structure, okay? So if we look at this, we see that there's a plate here, and it's just repeated in a zigzag fashion. We're going to do that by creating, by making this rectangle and then rotating it, mirroring it, and then we can copy or array. So those are all the commands that we're going to practice here. Okay, so here you have, also I just wanna, if I'm going too quickly, so I think for this we're probably fine, but if I am going too quickly, can you say something? I see that you have a chat here, which is great, but I actually cannot see that while I'm working. So I have one screen up, but I can't see that. So you're gonna have to tell me audioly to slow down, okay? All right, so, yep. Oh, you're saying this one? Uh, oh, okay, thank you. Okay, and then can I bring it down here? Oh, that's probably true. Yeah, I was wondering why it was, why it went away, but I guess I got a little too crazy. I don't usually mess with these. Honestly, I don't touch them. They're because of this. Yeah. See, I thought, usually you can like, it just like accepts it. You know, like if you move this, it moves back and forth and then it just boop shows up.
I think you might be able to fix it by typing 4view. I don't know if it works with the Windows, but it...
4view.
Or new other viewport. One of those two should work, maybe. You have to type 4view with the number.
Oh, okay. 4view. Hey, cool. Thank you. God, I've never had to use that before. Awesome. All right. Well, okay, so now you just learned this. This is kind of how the class goes, because there's some stuff that I've never used, like ever. Uh, and yeah, you might have to help me sometimes, because I don't use it. The same thing for Grasshopper too, actually. There are a couple of times where it's something new to me, and it's only because I've gotten really used to, and this will probably happen, I think, for most people, is you get really used to modeling and working with the same interface, and you just never have to, come across that problem. So sorry if I'm a cruddy teacher sometimes, but hopefully you guys are better, better students, or better teachers than me. Okay, so all right, so here we're going to either copy, like what I just did. Okay, so I selected this. Okay, I selected it with my left clicker. I'm just letting you know that because I should also go over the mouse commands for you. So if you right click and hold, you orbit. If you shift right, you pan. Okay, if I left click, I select. And if I shift left click, I can select more than one. Okay, I still have my shift held and I can select more into my selection. If I control left click, I can deselect from that selection. Okay, so those are just nice mouse commands so that you know you can control your interface a little bit more. Okay, and then of course scroll. Okay. All right, so if I select this, I can either mirror this or I can copy. So I typed in copy first, which I just take the 1 point and I move it over and I create a copy of it so that I have 2 of these. Okay. The other thing to note here is that you'll see that when I select things, that this what is called a gumball comes up, and the gumball is it's a useful tool. However, it can also make your work a little sloppy sometimes if you aren't using it with precision. And if you're just modeling, like free modeling, and you're just figuring out form and you want things kind of right in space, but you know you're going to have to go back and remodel it, it's a great tool. It's also very useful if you say want to move this over an exact amount, so that and I've done that before where I say I have curves in space and I want to work on something. Okay, I can select those curves and I can move them over a determined distance, and that way I know that those are 20 feet over. When I am done modeling this over here, I can then select them and move them back minus 20. Okay, and that is just done by selection, and then you click on these arrows, right, that are also working with your XY system, coordinate system. So you have X here, and you have Y here, and you have Z here. Okay. The same thing goes for these buttons. These are scaling buttons, or scaling interfaces, I guess. They're not really buttons. So if you click on those, if I did shift click, I can scale to a certain distance. So if I want it twice the size, I can, it will uniformly scale it. Okay, Control Z. Control Z is undo, and it's very nice. If I want to scale in only one direction, I can click on this and I can type in my scale and it will scale it in one direction. Okay, so I suggest playing with Gumball and just kind of knowing what it is. Then you also have your rotations here. So if I click on this and I want to rotate it off its axis, it will use this center point, right, its centroid, as the axis for rotation. Because it is about the z-axis, it is in blue, and you can see where the arrows are, right? They're moving. So if I rotate it this way, right? If I rotate it counterclockwise 20, it will move it counterclockwise 20 degrees. Okay. If I rotate it the other way, I can do minus 20, and that will move it back into place. So you can do that in other directions as well. So say I want this at 90 degrees, I want it to change the plane. I just type that in here. Okay. All right, I think that's enough for Gumball. We're actually going to use, though, for rotation right now, we're going to use the rotate 3D command. So there are actually 2 rotate commands. So one is rotate. So if I type that in, the center of rotation, it's going to only rotate in this XY plane. So thank you for my top view back, because it will only rotate in this view. Even if I am in the front space, it's only going to rotate in that C plane that I have. Okay, so if I click in this, I have to select a center point of rotation. So I've selected, this 0, 0 point, and can then control my angle of rotation. Okay, but for our exercise, we actually want to rotate it about a specific axis. So this axis is selected using rotate 3D. So if I type that in, I can select the objects to rotate. Okay, so I want to rotate just that one, right, because he's actually at a different angle. If I select enter, I can do choose the rotation axis. If I select this axis here, it will then show me the circle of rotation that I have open to me, right? And that is in the z-axis, really, right? It's parallel to the z-axis. It is perpendicular to the axis I just created. Okay, so then I can click on this, and then I should be able to type in, say, 30, and oh, I rotated it down. I did the exact opposite of what I wanted to do. So I guess I was wrong. It should be minus 30. Okay, and I think that's because I clicked this as the start and this is the end, which would mean that is counterclockwise. It will move this way. So I have to do minus 30 to actually rotate it back up. Okay, so for this side, it should be 30 that we rotate it. So if we do rotate 3D, okay, we did our axis. Now we click the point that we want to rotate. I should be able to type in 30, and yeah, now we have a nice little butterfly. Okay, so once we have him, now we actually could have done that in two different ways, right? We could rotate each one of these separately, or so this is another neat trick, is if I select this and I hold Alt and I move this over, so I type in, it will create a copy for me in space. Okay, so I'll do that one more time. So I selected it, I held Alt while I also clicked on this move arrow in space. Okay, and I typed in 10, but you can type in whatever, of course, you need to work on this other option. Okay, so you'll notice that the fun of Rhino is that there isn't one right way to do something. There are a number of ways to solve a problem, and you know, like I was saying, like I've gotten used to solving the same problems over and over again, and you just kind of start modeling in a particular way. But that doesn't mean it's the right way. It's just the way that you've gotten used to. So, you know, if there's a better way to do something, and if you've discovered a new way, please share, because you will save somebody else time. And it's amazing. Like there are things that I didn't know existed, and I've been doing them one way forever. And you know, and then I find out this new command, and it saves me like 10 seconds, which if you're modeling similar things for a while, it can save you like a few minutes. Yeah, it's really helpful to have to keep growing your command base, and not just think that you have, you know, once you figured it out, that's the only way to do it. Yeah. So right. So the other way to do this is to select and use mirror. Okay, which we already did, right? And that's again about an axis. So this is the axis here that I am selecting. I'm selecting the start of this, and then the start corner of this and the end corner of this. And you can see that I create the same shape. I can also create a copy in space this way. I can also do it at the top here, right? So I can select this corner and mirror it about that surface. Just so you know, that mirror is a very helpful command sometimes. So I've created the exact same shape using both we copied it in flat space and then we rotated it both, or I just did one and then I mirrored it. You can see where as you start to get used to modeling, you'll figure out the quickest way to do something. And once you do that, it will just be kind of second nature. If you know that this is the shape you need to create, you'll probably choose the mirror command versus the two flat planes to start off with, which is more just an exercise for us. Okay, so then the other thing that you'll want to know is how to make these curves, right? So these are curves. In a Rhino, everything is either a point, curve, or surface, or mesh, which you can see here. Mesh is the other thing I've created. I don't typically have points visible. We are working in a world of points, right? The grid snap, the O snap, these things are the points in space. They're just not, not visible to us at the moment. But with those, we create curves, and those curves can be actual lines with curves, or they can just be lines in space, lines with curvature, there we go, or lines in space that are just straight segments. So here we just have a plain segment, a plain segmented plane. So if we select that, we should be able to type in planar surface. And planar surface will use those edges to create a surface bound by them. Okay, and in the view I'm in right now, which is wireframe, so if you go up to this window selector here, you can choose your view options. So if you want to see what this shaded, it looks like shaded, you just click on that, and you should be able to see that surface a little clearer, as well as what is a curve versus what is a surface. You can also choose ghosted. That's usually what I'm modeling in. I like ghosted because I can always kind of see the geometry beyond. You can see how I can see that grid axis beyond. When you start to get to more complex things, you can see it's clearer as to what you're clicking on sometimes. Also just where you are in modeling space. So I strongly suggest that once you get to, wireframe's fine for now. We're pretty simple, but once you get to like more, complex models with a lot of layers and a lot of stuff going on, I really like ghosted. However, you can work in whatever you want to, because you'll probably find your own preferences. And then the other thing to note is you have rendered here, which rendered can be a very nice option, because you can actually use these things, use the rendered view as a way of visualizing your geometry, right? So you can see here that it gives me a little bit of shading. And this is kind of, I'm giving you an intro to this. I know we might run out of time today for the second part of the Grasshopper experiment, but I do kind of think it's useful for your assignments to know that you have these view options, because you can use them to your advantage. You can take this view and export this view. You can do file, you can do print to print a view, okay? You can also do, so say I want just this in space. I can zoom in here. I can get it to look quite nice. Okay, so if I want an axon view, I can do view capture to file. Okay, so notice how it's always underscore, right? It's this underscore and then command. That's typically how these work. You can also just type it in. But view capture to file is very, very useful for taking your geometry and bringing it into a presentation. So for instance, right now I have my perspective view, but I could also choose my top view. Those obviously aren't set up. I need to change the view interface, the display option for it. But so say I want to bring this into my InDesign, I can choose whether or not my grid is exposed, my world axis, C-axis. I can choose whether or not these things are there. I typically have them off because I just want the geometry. And then I can choose my transparent background. And that is key. You know, the ability for this to already be trimmed and then to bring it in as a PNG to my other software so that I can manipulate it makes my world much easier. I can also choose scale. So the scale will give me the resolution, but I can also change the resolution here. This is telling me what it is right now, which is the size of the viewport, right? I can choose smaller or I can choose larger, right? Just know that as you go up in these numbers, your processing time might take longer, which is fine. If it depends on your processor and how much time you have, I guess. But just know that the, the larger the image, especially when you get into V-Ray and stuff, the larger the image, the more time it's going to take. Okay, so and then you'll need to choose a location. So I'm just going to say test one, but I can type in the file name and then I'll type in PNG, and that will give me the transparent background that I need for, say, your homework assignments. As every week you're going to be building your graphics control. This I think will be a good first step for helping you with that. Okay, I'm not going to save this because I don't really need it, but that's a nice useful setting. Also for that, sorry, I know we should be modeling, but it's just these are helpful things as you're going to be working with your model, right? You know, there's the modeling part and then there's everything else. It's all the other tricks and of the trade that help you to visualize that model that you have worked so hard on. Okay, so I'm going to do that again because I realized I did that while I was talking about something else. So in order to change these settings, so these are all display options, right? But there are settings behind those display options that you can change to benefit your, to benefit your view. So say I want sharper shadows or a brighter sun for my render, or for my shaded, I want like different colors or a different background. I can change this to all white. Or if I want to see curves, I can go into my tools and go to options. I can also type in options. And this will be your Rhino options menu. Okay, this is also another interface where you can control the grid, hatches, line types. You know, this get maybe a little familiar with it. Units are here as well. Okay, instead of typing it in or clicking the interface here, you have units. What I want to go to is the view and then the display modes. So you can see how these are the different display modes. I can create a new one, or I can import as well. So if there is one that I've saved from a different project or program, whatever, I can import that. I can save it and then import it to here and use those same settings. I can also create a new one here that I want to use specifically for renders. I don't want to get to it, but like if you want to use a matte ID background, which is each one of these has a different color and it's just a solid color that then you can then use as a backdrop in Photoshop. It's amazing and it saves you a lot of time, but you have to set that display mode up beforehand. So it's just good to know that you have it here. We're not going to, of course, go into this too much today, but as you click into this, you can see that this is where you can control your background. So use render settings, okay, fine, but I could also control it myself by changing it to solid color, okay? So see, now it's a floating white thing in a background. It's black background, pretty cool. You can also do gradient colors. You can, X-ray wires, whatever you want to show. This is where you can control it. I don't want to go too in depth. I just want you to know that it exists. Okay. And the same thing. No, I liked it white though. Back to white. Thank you. Okay. Same thing for your shaded and ghosted and any of these other views. So I suggest, playing with them in these first couple of weeks and kind of trying to find a view setting that you really like and that works for you, because then you can use that to export these images and keep a certain level of style, like a certain standard of style, I would say, for yourself. So if I'm going to do all clay with specific line work over it, you can start to kind of create your own template so that these weekly assignments, you don't even have to you don't have to think too hard about the graphics. You have already set up a graphic style that you want to follow. And if you follow that through, you can start to tweak it and get it to a much more detailed view, by say midterm or finals. I kind of, yeah, I think that is a good thing for you in general, because as you work on your portfolio, you're going to have that in there anyways. Whether or not you realize it now, you're already working towards a certain graphic preference, I would say. There's certain fonts that you like, there's certain colors, there's certain styles and everything, and you're going to, it's going to show in your portfolio. So this is a good opportunity for you to think about exactly what that means to you, and what what do you hate the color pink and you never want to see pink on your presentation, or do you love magenta and it's going to be magenta everywhere? It I would say test it out and see what really moves you. The font too, because if you I've noticed portfolios that are like the tightest, they will always use the same font throughout the entire portfolio. So I know project by project, they kind of can change, right? Like some projects might be, more loud and bright colored, and other projects might be softer, and that's okay. But when you start to think about your overall general style, it should have some sort of cohesion, I would think. So if anything, a cohesion within the project itself. So one board shouldn't be in all Arial, and then the other one in all Arial and magenta, and the other one be in like Gothic, Century Gothic, and like cyan. They look like two different projects. So just another part of design communication. And I went down a spiral, didn't I? Sorry. Okay, back to modeling. You guys can yell at me, like that usually is what happens in class. Like, hey, like we want to go back to Rhino space. Okay, so what we were doing over here was we were talking about visualizing this surface. So I'm going to change this back to ghosted so that I can actually see the surface. And what I can do is I can also click on this and type in planar surface to create that there as well. Or I can mirror it or whatever I want. I could have just created one of these in space and then mirrored it. There are a number of options. The goal is always the same. It's to create a specific shape. Okay. So the other part of this is that we've created this shape, but now we want to array it or copy it in space. What is this? 1, 2, 3, 4 of them. You can do as many as you want, but I'm first going to join. Join is very helpful for surfaces. What I have done now is I have joined these two surfaces along this this line. That means I only select one surface, and the whole thing is now recognized as one unit. Okay, I can select that, and I have options to me as to how to create this. I can either copy and paste, which is fairly easy. I can type copy, I choose a point, and I copy it over in space. Okay, I want to make sure that when I do copy this in space, that I am clicking on each and every corner. Okay, it helps to have your O snap on. O snap is it's like grid snap, but O snap is helping you by snapping to the geometry. So I can use this interface down here to help me control which part of the geometry I am snapping to. So for instance, I have, you can see how there's certain things that are checked and certain things that are unchecked. I typically model with these on, but I sometimes will turn on center because center is useful when trying to work with a circle, say, or an odd object. But usually it's a circle and I'm trying to find the center of it, and because I need to rotate it or manipulate it or do something to it. But these really help you because so I'll do copy again. As you're clicking on it, see this will say this is my intersection. Okay, so this is the intersection between one and the other. If I move down in the surface, you can see it hovers and it tells me this is your midpoint. So my midpoint is also sometimes useful when if I want to do midpoint to midpoint or something, right? So it's just a nice thing to have. If it's off, you will not see those options. Okay, so if I click on this, I do copy. I don't have anything to click onto. It will not recognize that those are intersections. In fact, what it's doing now is it's clicking to my grid because my grid snap is still on. Okay, so I typically turn my grid snap off when I am working with just the geometry, and I will leave my O snap on so that I can control only the geometry and I don't accidentally click my grid. Okay, it's just a good working workflow. Okay, so if I click this, now I can see that these things come on, and I can also see that it tells me intersection and point. Same thing for here, it tells me it's perpendicular and it's an intersection. So that's what I want to see, because that way I know I'm modeling accurately and that it is nowhere else in space. It's not up here, it's not over here. It is exactly in space where I need it to be. Okay, and that's important for this next part. Okay, actually, no, we're going to try this. So I showed you copy and paste. Now I'm also going to hold Alt and copy one of these over so that I can also show you array. Okay, so copy and paste was one way that we can create a folded plate structure, but if we do array linear will do the same thing where we click the number of items. So say this was 4. I need to click my first point of reference and then my next point of reference. And again, I'm using OSnap to control where I'm clicking for that. If I click up, notice it shifts. Okay. If I click down, it shifts. It will array wherever that that direction that I'm creating is towards. Okay. But you can see we created the exact same thing. Okay. No one way is better than the other, but for this, it doesn't really matter. Okay, so the other part of this is that I right now have curves, right? I have curves and I have surfaces in the same place. Meaning, if I want to make this all into one unit, if I do this and click join, that will all, it should just join the surfaces together and I should not have a problem with the curves, but I don't really want them in my modeling space. Okay, so what I do is I actually like to create a number of layers over here. So you have your layers and your properties and your named views. Okay, those are the 3 that I'm going to go over today. You quite possibly will have a number of other tabs. You can ignore those for today. These are what are useful for right now. To find the other tabs, so if you say can't find layers and you don't see these, just click on this little settings, look down here, and you should be able to find your layers, your named views, and your properties. And those things should all be checked. Okay. Other things that you might see are like sun and environment. Sometimes your help or your display might be also there as a default. It depends. But just know that that's where you can control it. Right, so for layers then, you can see I've set up curves, surfaces, and mesh. Curves are anything that are, of course, in line or have curvature or whatever. They're a curve in a Rhino world is just a single line with, it doesn't matter if it's curved or not or whatever. It's just a line base. So I'm going to actually do select, SELCRV, to select all of my curves in the view. Okay. When it does that, it it should select every curve that is in my modeling space. And then I can go over to here and I can do properties. If I look at properties, it will tell me what my selection is. And it says that I have 2 closed curves and my layer is default. However, I would like those to be on my curves layer. Notice they went away because I have my curves layer turned off. If I turn them on, we'll see that I actually have a myriad of curves all in the same space because that is sloppy modeling. But here, we'll move those over. There we go. Okay, and same thing with these guys. These were old. Okay, so now you can see that I have my my curves on my red layer, right? I can also change that color. One guideline for you is I would say actually red is not a great color to have as your curves because of Grasshopper. Well, we'll see. Green is also not a good choice for your curves color because of, again, Grasshopper. And yellow is not a good color for your curves because of Rhino. And you'll see that if I select this, what does it turn? It turns yellow. And actually that's true for pretty much everything. You do not want to have yellow as your option over here, or your layer color, because if your settings are set up to show your layer color, it will always look like it's selected. And if it's not, it can get confusing and you can mess up your model. So anyway, so I'm going to change this from red to let's say magenta. Okay, all right, so now I have magenta curves. And because they're on their own layer, I can simply turn them off when I don't want to use them. If I still want to see them, but I don't want to interact with them, I can click lock. Okay, and I can select them all of my surfaces, right, that are on the default layer, and I can change those to my surfaces layer. Okay, so and you should be able to just create, I realize I have these already set up, so I'm going to show you, you can create new layers by just clicking this button here and entering your information. Info here. Okay, and that will be the new layer that you can then add things to. You can also right click and do delete layer, rename it, whatever. I'm going to delete this one too because it's not important. Okay, all right, so this is now our surfaces, and I have my curves layer locked, so I can't select it. See, I'm trying to select this guy over here. He doesn't select. Okay, if I select all of them and I click join, now I should have one continuous surface, and in that these are now joined at hinges, right? Just like we had joined this, we have now joined every single unit to make one large unit. This is useful in that you want, so if we look at this, we'll see that this is has a certain thickness to it. If we select it and I do zoom selected, this is so useful because sometimes you'll notice that your zoom gets a little off, right? It wants to go to the geometry you're just working on or some other point in space, and then it doesn't want to zoom in as easily. If you click on your geometry and you click zoom selected, it will reorient your camera to that new object. Okay, so if we look at the goal object, this has a certain thickness to it, and it's very cleanly connected in that surface is offset from the bottom surface, and there is no geometry in between. There is a clean line here and a clean line here, and those both sides have you can see it's a clean 4-point surface for each side. And I'm only mentioning this because if I were to do, okay, so yeah, I'm going to copy this and show you. All right, so right now this one is joined, right? And this one, if I type in explode, which is a fun command, I have just exploded all of these surfaces from that join that I had together. And now they're each separate surfaces. Okay. Now, if I use the same command on both, we'll see what happens. So if I select this one surface and I type in offset surface, you should have a number of options, right? But I'm doing offset SRF, offset surface. Okay. It will give me the option of which direction to offset, right? So to create that same perfect 4-point surface, just offset from the original. Notice how all of my arrows are going down. So it's going to hold the surface that we've created where it is, and it's going to offset in that direction. If I do flip all, so if I click on that, it will invert that option. It will still hold this option here, but it will flip and it will offset in the opposite direction. I'm explaining this because quite often, if you are modeling an object that needs to, say, be 3D printed and fit into a model perfectly, you want to be very careful as to which direction you are offsetting this object to be 3D printed. Okay, so if you offset it the wrong way, it might not fit in the model. So you just want to be very certain that you hold whichever surface or edge you need to hold, and that everything else works the opposite way. Okay, the other option here is that I have distance. Okay, so my distance I have set to 0.25, which is in feet. So my 0.25 is actually 3 inches. I can change that by either typing in D or clicking on it, and I type in, say, 0.5. Okay, that's going to change it now to 6 inches offset. The other thing is a corner, so this will be sharp or round. That's just going to change the edge condition. And then solid is going to be whether or not, you see this says solid over here, this surface edge, right? That creates a solid of this. If I do no, that means it will only create the offset surface. So it will have the original surface and you'll have the offset surface, but you will not have the enclosed edge that you see here. Okay, so I do want solid, yes, because if we're going to 3D print this, we'll need a watertight vessel. Okay, that's the key to 3D printing. Everything has to be quote unquote watertight in the world of the model setup. Okay, so I'm going to click yes or enter for it to offset. And now I should have a perfectly enclosed object for me to then mesh and then send to the 3D printer. Okay, so that's if they're all connected. If they're not all connected like this, what's going to happen? Let's see. So we'll type in offset surface. We'll do flip all, and then we'll type in enter. Okay, so you can see if I zoom in here, what has happened. There's each one of these offset individually. So because they were not joined as one surface, Rhino recognized them as what they are, each an individual unit. So I don't have a clean unified object. I have 8 clean objects that are not unified. So that's why you want to know to join or even Boolean union before you go ahead and offset and try to create a watertight object. All right. So the last little bit of what you need to know is that to prep for the 3D printer does not accept this surface information. It will only accept meshes. So that means you need to select your geometry and then type in mesh in order to create a meshed surface of your NURB surface. Okay, so type in enter when you click mesh, and you can choose however complex you want it to be. So because these are simple planes, it doesn't really matter. It's going to create the same amount of planes, really. However, if you had, say, a round object, something with complex curvature, you're probably going to want to do more polygons, because more polygons will it will create a finer detail of that curvature. If you do fewer polygons, it'll start to kind of abstract it, which is usually not what you want, right? You've modeled it to a certain precision. You want that precision to be reflected in the model. So you should probably do something more along this line. If you do that and you have a very large model that is very complex, you should know that that might take a lot of time. Okay, so if you're working on a deadline and you've given yourself only, say, 10 hours to get this done, which I hope you don't do, because 3D printing, you have to wait in line. It takes a lot longer than that. So say you have like 2 days to get it done. You need to know that it might take a while for that to be produced, and then also to 3D print it too, right? The larger the 3D print, the more complex it is, the longer it will take, especially by volume. Okay, so we're going to bring this down to the middle, click OK, and you can see that it's created for us a nice mesh. Okay, notice how it's in the exact same space as my poly surface. So that's what this really is. It's a collection of surfaces, so it is poly surface. So if I click over here, because they are in the same Rhino space, Rhino gives me a selection menu to choose between one or the other. Okay, so I can click on this and I can click on the mesh. It will select the mesh for me. You will want to control this by giving it a different layer, right? So I have created a new layer called mesh. I change that over here. Okay, so from surface to mesh, and notice my mesh is off. If I turn that on, you can see my original mesh that I did, which I'm going to delete. And now that it has a different color, right? I changed turquoise or whatever, cyan. But now I can see that that is in the same Rhino space. I also see that it's different, right? Because they were both white before. If I turn my surfaces off, I can see that. I have it over here, and I can just move it over in Rhino space. And now I have the ability to work with it as I need to for 3D printing. Okay. Another thing to note is a way to visually see that this is a watertight object. Just to do a visual check. You can also run software, which is a different thing, but and it will check whether or not it's watertight for you. You can do a quick check yourself by making a clipping plane. So clipping plane is a way to do a section cut. So clipping plane will control, it will create a clipping plane, I guess. I don't know, a section for your object, and you can control which view you want to see that in. So for instance, if I click here in this space, it's going to work in my X, Y, C-plane coordinate system, right? So if I do that, it's only going to section cut this way, which is still useful. I can go in and I can see that, in fact, those are each watertight objects, but I really want it the other way. So I can use my gumball to control the clipping plane by rotating it 90 degrees and shifting it over in space, and then coming in and seeing that, oh yes, indeed, that's exactly what I want. I want to see that that has continuous curvature all around. You know, if I were to do it with the other example that we showed, so my surfaces, did I delete that? I don't remember. Oops. I did delete it. Okay, well, if I were to do it with the other one, I would, even though I could already see that each one was a separate surface, it would tell me right away that I have a problem and that I need to remodel it so that it is a watertight object. Here our object looks pretty good, and that we're probably going to be okay when we do the check before the print. Okay. In clipping plane here, you can see also that I have it on its own layer. So I've already created one, so I can delete this. And I have it locked so that I don't accidentally interact with it. I had it off. It's just in the background. I put it under my default so that I know where it is at all times, and I can turn it on and off as I need to. You can also change the viewport settings where you're seeing your clipping plane. So if I go to my Properties tab, well, I have it selected, of course. I can go to this clipping plane button, and if I click on Flip Direction, it will reorient the clipping plane. Now notice I'm not seeing anything happen, right? That's because notice none of my model views are checked. So if I check perspective, now it will create that section cut in my perspective view. And if I do go back to my rendered view, I can see that it also creates this nice black line for me. Notice I have my curves on, so if I wanted to, I could have my curves shown here. If I do dupe border, oh, I have to actually have it as surfaces, right? Okay. So if I select this and I do explode, then I can do dupe border, and then I should be able to see those curves in space. That's one way of doing it. You can also change your display option settings, which are again here, where you can see your ISO curves. But it's maybe a little too going down the rabbit hole again, so I'm going to pull back. But anyway, so that's just a nice thing to know, that you can control that, and that you can create these section views for your homework, but also for your studio assignments as you work towards them. Okay, so all right, I think that's good for the first exercise. I'm going to give you like a 5-10 minute break. So if we say 10-15, that's like 7 minutes for a water, restroom, whatever. I think our class goes to, is it 11? Oh, 10:50. Okay, so we don't really have too much time, but that will give us enough time to do the next exercise. So yeah, 35 minutes. We'll walk through the next one pretty quickly. Sorry, I took a lot of time to walk through the Rhino interface. So, all right, is everybody still there? Are you sleeping? Still here? Okay, good. All right, cool. You're here? All right, good. Yay. All right. Glad to know I wasn't just talking to myself that whole time, you know? Okay, cool. All right, so let's say 10-15, so I'll just give you like 6 minutes and get some water and you do whatever you need to do. Okay, so I'm just going to turn off my camera and my mic. I'm going to work on it for, yeah, maybe let me think about it, because I do want to get to the interface. I think there's just not much time. We have that video link is what I'm thinking, and so if you can reference that and do that exercise, it would help you. But like how about I'll do an overview of it, but I don't think we can get into the exercise, because I think that, honestly, I think we were reaching for the stars trying to do that and the intro class. Okay.
Where's the video link again?
I'm going to send it to you in an email following this, okay?
Okay, alright, yeah, sounds good.
Okay, cool. All right, so I'll be back in a few minutes. Okay. Oh. Actually, I'm gonna do this right now. I think I should be able to do this. Okay. Should say Professor Palooza, huh? Okay. Okay. All right. So I'm trying out this group chat thing. So let me know if you see that in your email. You should just have gotten a link here. You can also check the group itself, I think, and see that conversation. But I'm not seeing it here. I've obviously not used this before, so we will see. Okay, well, if anything, did you guys get an email? Otherwise, yeah, okay, great, awesome, cool. Otherwise, I posted the link here as well. So I was just thinking, I think what I'm going to do is I'm going to let you guys do that tutorial on your own at home. I'm going to do right now is I'm going to walk through, like just like I did for Grasshopper or for Rhino, and explaining how Rhino space works. I'm going to now talk through what we did in Rhino space and Grasshopper space, so that you can kind of get familiar with Grasshopper. It's not exactly what the tutorial is. So, you know, it won't be a repetition, I guess. But what we just did in class right now is this first part of this. The second part of that tutorial is actually this other tessellation. So if I turn this off, here. Okay, so this guy is the second part of that tutorial. And then if you go to the folding plate, this is what I wanted to get. We're not going to get through this in 30 minutes. Each one of these is like 30 minutes on its own. So it does help you. Like these are the reason he posted these and wanted to do this is because they simplify the introduction to Grasshopper, and you do the same thing in Rhino space and you do the same thing in Grasshopper space, and you can see how they're similar and different. It's just a good introduction to your first exercise in Grasshopper. However, if we do it right now with this folded plate, I think that also will be a good intro to you with just me walking you through it. So if you haven't already, you can type in Grasshopper to pull up your Grasshopper interface window. Okay, so I'm going to give you a second to do that because I know some people might take a little time. Okay. I'm also going to turn off my mesh, and I'm going to unlock these things, and I'm going to move them over in Grasshopper space, or in Rhino space, so I can work in Grasshopper here. Okay. Okay, so Grasshopper. I'm going to assume that if some people have not used Rhino, that you've also not used Grasshopper, since you kind of need to know, you need to at least have worked in Rhino to have used Grasshopper. What Grasshopper is it's an interface to parametrically control geometry in your Rhino space. So it is kind of like a world within the world of Rhino. And then within Grasshopper itself, there are other worlds. So for instance, you will probably have, and it depends on if you're working on, I guess, the school computers. So if you're doing the virtual computer lab, you might have different panels up here that they have installed, different plugins. If you have a raw Grasshopper, so this is the first time you've downloaded it and are opening it, you will probably have all of these tabs up here up into display, is my guess. These other ones are added plugins that you can get from online. So we're not going to, you're not going to need to know that this week because I don't want to spend too much time on it. But just know that there's like a basic interface, and then there's all of these other interfaces that you can add. The only other one I think that we're actually going to use in this class is Weaverbird. So when you saw that on the software selections, right, you get things you need to have. You might have wondered what Weaverbird is and what to do, how to get it. This is where you will need to import it, or like install it. Sorry, well, install it too. So we can do that later because that's not for a couple weeks. So for right now, you'll want these basic tabs. Under each one are different controls. Okay, so Grasshopper works with a visual-based scripting language. So, there's general computer scripting. I'm sure some of you have had courses on it. My guess is maybe Python, or even such things as HTML or JavaScript or something like that. I don't know if you took coding in high school, but this is a visual based scripting. So it's, it's for architects, it's for designers, it's for people who don't want to type in all their code. They want to have a nice little boxes for the geometry and wires all over. Yeah, so to get started with Grasshopper, what you need to do is you need to click on the canvas. Notice it's giving me all these options. These are old scripts that I have done, and I can open them here directly, right? But to start a new script, all I need to do is really click on the canvas or drag a component from up here onto the canvas to begin a new script. Okay, so it's relatively simple in that interface for it. All right, so all right, let's get started. So the other thing with Grasshopper is the way you think about Rhino space. So the way we did our rectangle here and the rotation and all those commands are very similar in Grasshopper, and yet sometimes a little different in the way that you have to think about every step of the process. You know, the commands that you're inputting in this thing, and you type in a command for rectangle, and then you have sub entries where you type in the start point and the end point, and you can click on space, and it's more interactive in a very blunt way, I guess. It's very simple. This has a more of a dynamic approach in that you are entering parameters that you can change over time. Okay, and you think, okay, you can type in you can give it a point, but you can change the location of that point, and work with it parametrically, which is what parametric design is. So, okay, so let's double click in the canvas, and what we're going to start out with is the same thing that we started out with before. We start out with a rectangle. So you can type in the same command here. And if you look, you'll see a number of options, right? You always have a ton of options in here. You can do the 2-point rectangle. You can do rectangle on a plane, which is what we're going to do. There are also the number of other options. This one is a capsule. I just bit my lip. A capsule of it. And we'll get into that later, but these are more containers of geometry. So there are nodes like this that are interactive, where you have input on one side and you have output on the other, whereas this is more like it's just a container of that geometry. So if I were to input this rectangle into here, the information within this capsule is the same exact information that is in this. So it's not really doing anything. There's no function in these little containers, okay? It's the capsule with the input and outputs that are your controls in Grasshopper. Okay, so let's take a look at what exactly it's asking us to input. It asks us for a plane. So if we go over here and we look at that, we can see it's created a very generic rectangle about the 0, 0 point in the XY plane. Okay. All right. So if I want to change that plane, I can do I can type in different plane orientations. So I can do XY plane, which is exactly where it is. So it doesn't really help change anything right now. But I can also do YZ, which would change the orientation of it. Okay, so if I click and if I click on that and I bring that capsule in, I can see that it's in a different orientation, still about the 0, 0 point, but I would now be drawing in this plane, in the C plane. Okay, so just to know that the default for us right now works, but that is how you would control that. For the XY, so if we do, say, in the x-axis, which is our red here, say we do 3, okay, 3 feet, right, because we're still working in feet. I can plug that in, so I just double-clicked and I typed in a number. By doing that, it creates a number slider. And the number slider, when I do create a, I type in, say, 3 or 4 or 5 or something, it will create a default range of 0 to 10. And I can see that by either sliding this all the way down to 0 and sliding it all the way up to 10, Or I can right click on it, click edit, and then I can see that my minimum is set to 0 and my maximum is set to 10. I can also see what numeric value it is, so it's 3. If I want to change that here, I can adjust it. I can also adjust my minimum and my maximum, say I want my max to be 5. Okay, so now I've just made that number slider easier to use for my intent. The other part is that this integer numbers, that's what I'm working right now, right? It's one step for every number I have. So it's 0, 1, 2, 3, 4. If I want to do a floating point number will be a point number. So I have 1.5, I have 2.25. I can change the number of digits following that. So the precision that I want for each of my floating point numbers is controllable by just simply shifting this digits slider over here. So 3, 2, 1. And that's helpful for other exercises where you want a more specific point in space. Okay, so for us right now, n is perfectly fine, and we're going to leave it at that. Okay, so that is that's the number slider, and that's so that you can parametrically control the rectangle as you work with it. The other thing is that you can copy and paste for a number slider, or there's the option of inputting a specific number that you do not want to change. Sometimes that's very useful in that you always want to divide by a specific number, or you always want that number to be divided by that. You can click inside of a panel. So I pulled down a panel from here, or I can double click on the canvas and type in panel. Those are the two ways to enter a command in Grasshopper. It's double click or pull down one of your little buttons up here. But then you get this interface for a panel. And panels are very useful. You can use them as inputs. You can use them on the other end as outputs to see what exactly is being translated in here, right? I now know that my width is 3 and my height is 4, and I could see that before with my input for my x, but I didn't really know that my y was 4, right? We hadn't input that yet. So it's a nice way to visualize the information, especially if you're trying to figure out a script and you don't know exactly what the capsules are doing, right? The function is kind of hidden. You see all the inputs, you see all the outputs, but sometimes you don't really know how that is manifesting itself. So this is a great way to visualize that. Let's see if I disconnect, okay, so I've been plugging these in willy-nilly, right? But if I right-click this, I can also disconnect them. Okay, so to connect, you just drag and pull over. To disconnect, you can right-click. You can right-click and then click Disconnect Panel. Okay. So if I go over here and I say I want my Y size to always be 12, okay, randomly, it doesn't really matter. If I just type that into my panel, this is now a locked input. It's not parametric. It is always going to be 12 unless I go in and manually change that number. Okay. The other option is to copy and paste the number slider like I did. So it's just Control-C, Control-V, just like every other software. But if I click on this, or if I insert this into the Y instead, right? So notice how I had 1 inserted and then I didn't disconnect. What I did was I just took this other capsule and I said, no, I want it to actually be this, and it replaced it. If I wanted 2 values to be inserted into the same input, which here I don't want to, but if I did, if I hover over this and I click Shift, notice how a little plus sign shows up next to my arrow? That means I can add more than 1 into the same input. Okay. Now I have 2 rectangles, but I don't really want 2 rectangles, right? I have one at 3 and I have one at 12. So I'm going to delete that one because I actually do want it more parametric. Okay, so we'll do 2, we'll do 5. That looks okay. All right. You can do whatever you want, of course. This is just an exercise. But the one thing is that, as we're modeling, you can see, you should be seeing this actually in your Rhino space. If you're not, then you might not have this red geometry option selected. So over here are your selections for visualizing the geometry in Rhino space. If you click on this, it says don't draw any geometry. That means you're just scripting and you don't want to see it in Rhino space, so it's not visible. This is draw the wireframe of it, so you're just getting the outline, and then this is draw a shaded preview. So that would be when we're starting to add surfaces, this will start to show as a shaded plane. Okay. We'll get into these later. The other thing is actually we should save this. We should save both if you haven't already. Since we're getting close to the end of class, it's probably smart to do so. So you can go up to File and you can do Save Document. Just and this was actually A. Okay, so I'm going to save this file into my, file structure. I would create a folder for today's class. I would actually create a folder for the class in general, then create a subfolder with this class so that you always are organized and you know where you can find this information when you need to go back to it later. Today's probably not too advanced that you need to reference it too much, but as we move on in the semester, it will be useful. And same thing goes for your Rhino space. So I can click over here, like even with my Grasshopper window up, I can still interact with Rhino space, and I can do save as, or I can do just a general save if you've already done a save as, but it's a good habit to save every 30 minutes to an hour. It sounds like a lot, but when you start to get into a role of modeling, like you start really getting into it and you kind of lose track of time, and then your computer crashes, it's like probably one of the most painful and frustrating things because all of that rolling that you were doing doesn't really matter. You have to do it all over again. So it's good to save and save often. Okay, so rectangle. So you can see that this is being visualized now in our Rhino space. You can see that it is also giving us the plane in the Rhino space, and then there's also a radius, and this would be for the corner. So these corners are right now sharp, right? They each meet at one point in space. If I wanted to add a fillet to these, then I would add a specific radius, which would be like a number slider. Okay, and see how it adds a fillet to that radius, or a fillet to that rectangle. We don't need that right now, but just so you know what that capsule can do. All right, so let's rotate this. So remember how we created two rectangles before, and then we did the rotate, and then we tried out mirror. Well, with Grasshopper, you really just want to create one unit and then multiply it however you want to multiply it, because it is easy. Because it's parametric and you want to control just the one shape. I would suggest controlling that one shape with using the geometry of the original unit, and you'll see why in a second. Okay, so all right, so there's our rectangle. Now we want to rotate. So we have the same rotate options here. So we start with RO, and it gives us rotate, which is the same rotate in the, remember, XY plane. So it's just going to rotate about that axis. And we don't really want that, so we want rotate 3D, same as before. And if we select that, we get a new capsule to interact with. So with this capsule, we have the geometry that's at input, the angle, and the center and the axis. Okay, so the geometry is fairly easy, right? The geometry we want to rotate is the rectangle. If I take this little output and I put that into the geometry input, we'll see that it is rotating about the 0, 0 point in the XY axis. Makes sense. However, we wanted to rotate it about one of these edges, right? So if I say I want to rotate it about this edge, so if I look at it, this edge is on the not x-axis, it's on the y-axis. So I'm going to try out just typing in y, and it should give me what is called a vector. And a vector is just um, a directional control, I guess, using a point-to-point line in space. So there are orthogonal vectors, which are the x, the y, and the z. They all work in our regular axes. But you can also create a two-point vector. So not to get too advanced, but just so you understand what a vector is, two-point vector kind of explains that a lot better, where you have a vector as a start point and an end point, and then there's a certain value that's attributed to it. Okay, so you can have a start point and an end point, and then a certain amount that you want that vector to move in space or to control in space. So we'll get into that later, but that's kind of explains what exactly this is doing as a vector in our axis. Okay, so it looks like it's rotating about the correct axis. However, we need to find the correct angle. So the angle here, these are always in radians. So we actually need to, and I know that other parts of the world might work in different systems in different units, but for us it's degrees, 360 degrees. So what I need to do is I need to do two things to control my angle. I need to type in the degree I want to rotate it. So say I want to do 30, okay. All right, so I have 30, and then if I enter that in directly, notice that's not 30 degrees. That's because it's now 30 radian, and that is, I don't know about you, but I can't think like that. I don't know radian off the top of my head. I do know degrees. So if I type in radians, so RAD radians, it will give me a capsule that will translate my mode of thought of degrees into radians. And here is where I can actually control, now I can control this in a way that I understand it. Notice it's actually rotating down, which is fine. We could work with rotating down. But if I wanted to flip that, or if I wanted, you could type in 270, right? So that it rotates 270 degrees and it's more, it's up this way, right? So it would be going in the positive direction this way. I can also simply add a negative capsule to here. And that means that I can flip the direction of my rotation. Okay. So notice I had to put the negative after the 30, right? The number slider only has output because it's the raw input. So, so I have to do 30, change that to negative, and then input that into the degrees, which changes it to radians, which gives my rotate angle the the correct angle that I want it at. Okay. Notice the center doesn't really matter for us in this exercise, but the center again would be something like defining a point for it, which you can do by creating a point. You could do construct a point, which is here. We're not going to do that right now, but just so you know that if you wanted to control that, you can do construct a point, or you can do construct a plane. You can also click one of the other planes, right? What I showed you in the beginning, which was X, Y, Z, Y, whatever it is, you can change the center. Okay, we're almost out of time, so I'm going to quickly go through this. All right, so I actually didn't want that negative. I liked it the other way, so I'm going to flip it back. You can do it. You can do what you want to do. All right. So now that I have that, and I have my rectangle parametric, I can then take this and I can do the mirror command that we had done before in Rhino. So if I double click and I type in mirror, I will see that my mirror comes up with an input for geometry and for plane. Notice the default plane is set at this is my Y and my Z axis. So if I want to change that, I need to either construct a plane or move this plane. So I'm going to first put the geometry in here. Okay, we can see that it flips it about that plane. Okay. I wonder, I could also just work with it on that center plane. Let's do that right now because it's easier. Okay. It's quicker. Instead of constructing a plane and moving it and all that jazz. Okay, there we go. And now it's in the positive direction. I did want that negative, see? All right. Okay, so now I have my mirror, and then the plane, we're just going to leave it as is for the default. There again, if you wanted to, you could do construct plane. So if you're working on it as I had already started, you could do construct plane and then change your x-axis and y-axis. That takes a little time, and we have 6 minutes. Okay, so now that I have that geometry and I have that geometry, these look more like what we were working with before. And if I change my number slider over here at the beginning, I can see that I'm controlling this parametrically, the size, and I can make it longer or shorter, whatever I need to do. Okay, so that's the fun part of Grasshopper is, if we wanted to change the shape of this, we would be locked to it. We'd have to go back and model from scratch or change our curves and then do the whole process over again. Versus Grasshopper, you can adjust these as you work and figure out your shape that you want, scale and everything. Okay, so we have our mirrored shape, this shape. Okay, so now we want to do array, linear array. Okay, so what I'm going to do is I'm going to input both of my geometries, right? Because it has my geometry here, my geometry there. Okay, and we'll see what the exact direction is. Okay, so direction is working in the x direction. Okay, and there's a certain count that they have array set as a default for the array. We had 4, so that is pretty simple. We'll just click in 4. Okay, I'm going to do a number slider again so it's parametric. I can change it, right?
Professor, I'm following along, and it won't connect both of the geometries from the rotate plane from the mirror.
Okay, so you should be able to select, so why don't you input 1, and then if you select this other one and hold shift, you should see a positive square. See how it's hovering right there, and then input that as well. So both geometries. Did that go?
Yeah.
Awesome. Okay. All right. Sorry, I did that a little quickly. Okay. All right. So we have 4 minutes to do a vector. All right. So direction. Now we're back to vector. Vector is then the same thing we wanted before, which was this is now in the x direction, so we want the x vector. Okay, so we've done that. We know what a vector is. If I input that, that is going to work now as an x direction. But notice how I'm going to turn off all these. So I'm going to select. This is just because this is getting a little too crazy, right? How am I supposed to work with this? I have plane, and there's all this stuff. So I'm going to click on my canvas and drag my arrow over so that I select all of these capsules but the one that I want to see, right? If I select this, see how it turns green? Those are all of my arrays. That's what I want to work with. I don't want to work with all of these. So I'm going to select them all. I'm going to right click on the open canvas, not on any of the capsules. I want to right click on the canvas and I want to click preview off. You'll see them all change, and that means that these are all now dark gray and they are not visible in your Rhino space. And this is very useful when you're trying to model a Grasshopper script, and if you have all of your capsules on, it will eventually get really convoluted and confusing for you while you're trying to model in Rhino space. Okay. So if I click on this, you can see how it turns from red, which means it's not selected, to green, which means that's the geometry I have selected in this capsule. And that's why in Rhino space, if you have it set up to red or green, it's like, is that Rhino geometry or Grasshopper geometry? And it gets confusing. So yeah, just a good thing to note. Okay, so the last little bit here we need to add is the factor. Okay, so the factor is the amount that we want to move this in the x direction. So if I do just 4, it will move over 4 units. Okay, if I do 3, it'll move over then. But see how it doesn't have it's too loose. Like I don't have control of it moving from this point to this point in Rhino space. So what I need to do is I actually need to, and we're probably not going to have time, so I'm just going to explain it because I'm running out of time. I'm sorry. But what I need to do is I actually need to, and just for conceptually, I need to grab this point, and I need to grab this point, and I need to find out what that distance is. Okay, and I can do that by going back to my geometry, going to my rectangle, and I can do, I don't know, bang. Oh, shit, no, wait, what am I thinking? Blech. No, I'm deconstruct. Jesus. Okay, sorry. I'm getting nervous with it being time pressing. Deconstruct BREP. You can do, or you can do deconstruct in general, but deconstruct will give you the edges and the right. So deconstruct will give you the original that we had, the face of it, but we actually will want we want this point and we want this point location in this direction. So we will need to grab this geometry and then grab the x. We'll have to deconstruct this point to get the x x units. Okay, so we just hit 10:50. If you have 10 minutes, I can walk you through that. If you have somewhere else to be, that's perfectly fine. I'll keep recording this and you can watch the end of it if you need to go, okay? All right, so, all right. Okay, so I'm going to grab these vertices. So what I did was I did deconstruct BREP, which is taking my geometry and it is giving me the faces, which is the surfaces, the edges, which are the lines around the surface, and the vertices that make up the surface. I want to grab, Grasshopper works in lists, so if I bring my panel over, or if I pull it from here again, right, and I take a look at my list of points that make up my my rectangle, I actually want to grab this one here, the origin point, so I know that that is 0. But I want to grab this point, which I think is 0.1. It seems right, but what I can do is I can actually type in point list and visualize it. And if I do size is 1, point list, then I can visualize, and that's right. Okay, so I have 0, 1, 2, 3. So those are my points. about the rectangle. Okay, so if I want to control them, I need to grab a list item capsule. Okay, and don't worry, I will send out the script afterwards so that you have it as a reference as well. So if I'm going too quickly right now, I'm sorry. I will send this out. Okay, so I'm going to take my vertices and I'm going to input them into my list item. My list item then is going to give me one of those items, right? So it's going to give me the first one because it's grabbing from a particular index. So my index, copy and paste. If I look at this, my index is this. Okay, that's my output for my vertices. List item grabs the top one. Okay, so this default is set to 0. Okay, so if I want to change this, I can change the item that I want to select by either right-clicking, set integer, and I can change it to whatever, if I want 1, 2, or 3, whatever point I want. I can also do a number slider, and I can select 0.2, 0.1, whatever, and that will select then the number 2 on the list, that's the point, or number 1 on the list, and that's the output point. But this is useful in selecting items from lists. Okay, so if we want, say, 0.0, then I guess my default is fine. I have 0.0 as the start of my vector. But I want the distance, right? I want the amplitude to be this x distance. So I need to grab this x distance, 1.732, blah, 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 and use that as my amplitude for my vector in order to get my linear array to align perfectly from here to here. Okay, so I'm going to then do this because I don't want just one list item. I could copy and paste this, but I actually want to just do 1 and then 2. And if I do this, I can actually get, without even controlling the index input, I can now simply grab each of these points as an output. So all I did was zoom in and I clicked plus, 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 and now I have all 4 outputs of each of the 4 points. Okay, so if I have 0.0 that I want, that's the first point. Okay, and I can actually delete this, so it's just that. Okay, and then if I want to copy and paste, I can grab this, and now I have the second point. Okay. Okay, so that gives me this first one, but now I want to deconstruct. I want to get this point, and I want this to not be 1, but to be 0, right? Because I need the point to not the vector. Yeah, I want this value. So I'm going to deconstruct point. Okay, and if I do this, if I click from 0.1 into here, I will now have these values as separate integers, okay? Or floating point values actually in this case. So that's the number I want. I want it to move that distance, okay? So if I take my output from this, and I delete this factor, right? I'm zooming in back to the linear array, and I look at this and I say, okay, I don't want 3 because that doesn't actually work for me. I want this number. I can select my x component and input it into the factor. And now it should move over. Oh, why didn't you work? Oh, I actually want it times 2. Huh, right? Look at that. So if you look at it, it moved over exactly the number of points, but remember we mirrored this. So we actually have to move it over twice the distance. So it's an easy fix by doing multiply. So you can do multiplication. You take your x component. You can either right click set data item to 2, or use a panel. So I can also use that panel again and type in 2. Okay. Either one will work, but the result will then be twice the distance. And now my array should work as moving from this point to actually this point, right? I said this here to here, but we actually want to move here to here. Okay. And that's it. So 10 minutes over. Sorry, guys. And I know that was quick, so I will send you the script, and you can follow along, and let me know if you have any questions. Okay. I don't even know, is anybody still here? Oh, they're still humans. Okay. Hi. Hello. All right. So, did you? Was that clear on a good? Was that a good intro to Grasshopper for you, or was it a little too quick?
The end for me was a little too quick, but I think that was just because you were trying to make sure that like no one was late for their other class. But
Okay.
I kind of lost you after you said deconstruct the point. I just cut up to there, and then like after that's like where to put the different connectors.
Okay. All right. So if you want to stay on for a minute, I can show you exactly what to do. I can go over that. If anybody wants to stay on, you're welcome to. Again, so I will stay on here until probably like 11:50 on most days. So, or yeah, 11:50 is usually will be the cutoff because an hour after class. If you have questions and want to go over stuff, all right. If you have other classes, I understand, but it's usually like my office hour for students. Okay, so if we want to go over this, then so you said you were at deconstruct point. Okay, so we actually didn't really need this, but it's good. I was thinking of a 2-point vector. Sorry. All right, so if I have my output from my list item and I have it at deconstruct point, then if I move my panel over here, I can see that what that component is and double check that that is in fact the number I want. So I have my output set to this, and what I did was I input that into my linear array factor, right? So I went back to what we were talking about before, which was I need to array both of these geometries, right? Both wings in space in the x direction. And I needed a specific factor to do that, and so I tried to grab this x direction from this point to this point, but it only moved it. If I input that, you can see it only moves it half the distance I need to, right? Because it's only one of the wings. I actually need to move it over 2 wings. So what I did was I took a multiplication capsule, and I input the x component, so this 1.7 something, and then I input the data item as a right-click set data item to multiply by 2, right? So it's that number multiplied by 2. But to visualize it, we can enter 2 as a number slider. Thing is if you do that for multiplication, you can change that number too easily. So it's better to input the data item or to bring down a panel and put your 2 in so that you are locked to that ratio, right? In this instance, we don't want that to change. So we don't want that as a parametric option. We want it to always stay as 2, okay? All right, so then for your result, that should be exactly then twice the distance from that start to that start. So if I input that into what was my linear array, that factor, now it should move over exactly where I need it to be. Okay. Okay, cool. And now you can play with buttons, right? That's the fun part. So now you should be able to adjust the scale very easily, right? And it should all move together as one unit because it's all related to each other. It's all related to that original input. Okay. Awesome. Okay. Remember to save. Cool. All right. Does anyone else have questions? Um, Catch up somehow? Yeah, I'll save the Rhino file and the Grasshopper file, and I'll put them in the Google Drive. For the Google Drive has, let's see, where did I put it? Right here. Okay, so I have my assignments and my student folders. I'm going to put it in the assignments so that it's with your assignment, and then you'll have the in-class help. Okay? Okay, cool. All right. And then for homework, so I'm gonna leave the groups as they are for right now, so that you can find your why did I keep clicking on the wrong thing? Um, I'm gonna keep the groups as is, but you should find your name under Group A or Group B. I'm gonna do another check over because it looks like there are new students that maybe joined, and so I'll add more to the list, but I will not move you between groups. Okay. Um, you should be able to find your folder here, and then as you upload, you can add folders as you want. So if you want to organize this and however you need to, maybe you have it set up the same way we have the assignment set up, so that it's very clear that assignment 1, 2, 3, 4. That would be great. But this is kind of an opportunity for you to exercise good workflow. So this is your space. Okay. All right. I think that's all I've got for you today. Um, Let me know if you guys have questions on any of the homework. Yep.
I have one question. So I was noticing from the homework assignment that, I mean, parametric folded plate structure tessellation doesn't necessarily have to mean the example that you have above or what we did in class.
No.
So do we just have that much freedom in choosing what we want to do?
Yes, you do. That's a great question. Yeah. You should have fun. If you already, I mean, because there's such a range of levels coming in, so it's if you have a greater depth of understanding of Rhino and Grasshopper, you should have fun. This is meant for you to learn and use those skills and develop them and make them better. So show off. This is a class to show off. It's kind of cool. And if you're just learning, don't be afraid of showing off. Like I know it's intimidating if it's all new, but you'll get, don't worry, like you will get good and we'll get you there. And it's not about the more like yes, it's good to have more in-depth knowledge and more technique, but that comes with time. So if you're new to this, I understand. Like, don't worry about that. You're not competing. I understand, and it's more about how you present that work and how you develop that work, right? If I know you're starting from scratch and I see you like excel and you develop into a better level, like you're golden. Of course, I warn you, if you start off at too high a level, there are higher expectations, right? So,
That's what I was
yeah,
I
you
didn't
set your own bar.
really off the bat. That's what I was thinking.
Oh, well, you do whatever you feel is right, but if you're excited about it and interested in it, it should probably be good.
Okay, thank you.
Yeah. Okay. All right. Well, all right, looks like it's a little after 11, so I'm just gonna um, I'll sit here for a few minutes if anybody is working and has questions. Otherwise, I'll see you all next week.
Right, thank you again. See you next week.
All right. Bye. Good to see you.
When we save the Grasshopper file, do we have to also save the Rhino file separately?
Yes. Yes, you do. That's a great question. Right, so I saved the document, save the document as, we'll do that. When I save the document, you see how it only says save as Grasshopper type, right? And it only shows me the Grasshopper files in here. That's because this is working in its own platform within Rhino. So in order for my Grasshopper script to work with my Rhino script, and say we didn't do this today, but if I reference the geometry in my Rhino script, I want to make sure that I save both files and that they work together, if that makes any sense. So I want to make sure that I save this Rhino file because that will be my reference for my Grasshopper file if I'm referencing Rhino geometry. If I'm not, then it's not a big deal, and I can use any new Grasshopper or any new Rhino interface. Does that make any sense? We didn't do that, so for instance, okay, I'll show you right now if you have a moment. What I mean is that if I were to have a point here and I bring that into Rhino space, so right, I'm not working in Grasshopper space, I'm working in Rhino, and I input that here as a point at 0, 0, 0, and then I take that point and I reference that point in Grasshopper. So if I type in point and I use this as a point container, I can right click and I can do set one point. And that can then be my reference point in Rhino space. So I didn't, enter. Okay, so you can see if I have this selected, it now turns green in Grasshopper, but that's still a live point in Rhino. So I can move that freely, and it's being referenced in my Grasshopper. So if I reopen this script and I don't have that point in Rhino space, then I have to recreate that point in Rhino space and reset that one point. So that's what I'm saying, in that you want to, if you have reference geometry in Rhino space, it's very important that you save as that same Rhino file and the Grasshopper file with like a similar name so that you know that they go together, and that you just generally save their Rhino file, because you don't want to have to keep resetting all of these. If you have, say, like 10 points or a point and two curves and a surface, and it's just, it can get out of control. So it's smart to have both of these saved separately. Okay. You got it? Okay, cool. And you'll see that here too. You'll see that there's a Rhino and then there's a Grasshopper. And yeah, that's also a great way to check. Okay. Oh, I didn't show that. Well, I'll mention it in an email. You need to export high-res image, but that's also in the tutorial. Okay. I guess Sean, you're here twice. The, oh, okay. Okay, got it. I guess I can show you guys, but I should have gone over that as the last exercise. I was rushing. One thing you do need for the homework next week, and it's in the tutorials, is you need to know how to export a high-res image to add to your homework. So you have to go to File. It's very simple. Export high-res image. You make sure that you know where that image is going. So you select your, location, click Save, and then you can just click OK, and it will save there. But if you don't know it, it's tricky. So yeah, I'll probably send out an email letting people know that that's a thing. All right, any other questions from you guys? I don't see any in here. All right, you too. Um, so we'll call this. Of course, that's more of the array. We'll say the array distance. Did you guys have any questions, or should I sign off? Okay. All right, I'm gonna sign off. I'll see you guys next week. Thanks for attending today and your good questions. Bye.